All right then. Project pitch. First time for everything. I have never recorded myself doing any kind of project from start to finish. I've usually generally only thought to record myself after having success or utter failure. Very rarely does any of it ever reach the public eye. But this time I figured for kicks and giggles, I would go ahead and give it a try. I would go ahead and start with pitching my crazy idea and dragging you guys along with me. Had the solar boat project that was a success this year. Still going to continue to use that boat to grab and camp in the summers and things like that around here in the Northwest. But I figured the next boat project was going to be something a little bit more out there, something that hasn't been done nearly as much. Solar boats, electric boats in general, whether from scratch or from kits, is just becoming very much more prevalent. And it's very expensive and cost prohibitive. Now I'm looking at something that has the potential of being cheaper, but it has not been done very often. And generally, most successful examples of it were before I was even on this earth. It's been proven that it can be done full scale. There are dozens of examples of it being done on small scale, but I would like to go ahead and give the windmill boat a try. So windmill boat, wind-powered boat, wind turbine boat. There isn't really one solid name that I have found that it has been pegged as or coined, but there are lots of examples of people attempting it. Lots of success. There has been a few specific issues that have been the folly of many projects, specifically dealing with things with drag in the mechanical systems. That I'll go into later. This is just the initial pitch of just talking about the idea of just trying to build a small scale model of it, see if my twists really work, to see if I'm going at it a completely wrong way, whether I need to fit the mold or if I can find that shortcut. So, starting off with the history of these things, you have history going all the way back to the early 1900s of people trying to make this work. And generally, what they do is they have a massive windmill, wind turbine that is on a mast in the middle of the boat, and that spins a shaft or a belt or a chain that goes all the way down to a propeller in the water. And so right off the bat, you're dealing with extremely low RPMs compared to what a propeller normally would spin at. So generally, to solve some of the immediate issues, people have had to go to really big propellers in the water, and also trying to come up with the most efficient windmill design to harness that wind as much as possible. Now, obviously, the benefits, if you can succeed in making it work, is the ability to sail straight upwind. And matter of fact, the most efficient that people have, the most success that they see is when sailing directly upwind. Surprisingly, they're not that successful at sailing downwind. Partly is as soon as you start going the direction of the wind, the perceived wind slows down, where versus going against the wind, your perceived wind accelerates, which just increases the amount of energy that you're able to harness. There's a lot of skeptics that out there to say that's not practical. Just sail. You can attack a boat upwind just as fast as one of these can go. There's some truth to that, but it's all about in simplicity and keeping it easy to handle for one crew member, and also the ability to keep the boat on track no matter which way the wind is going, and not having to take up the entire shipping lane with tacking, having the maneuverability and the flexibility of going any direction would be a win. There are some large-scale examples of success when it comes to the windmill boat, or wind-powered boat. Would a gentleman by the name of Jim Bates, who has successfully built, as I can find scouring through the internet, is 2 boats. Most only know him of building 1 boat, and that is his first one, which was a catamaran. I don't have a lot of specs and numbers on it, but I have some pictures that I'm probably flipping through right now. But started off with a catamaran with a 3-blade windmill on it, and he had great success. He put thousands of miles on it. He would, at times, he mentions that he would actually have to feather the rotors out to slow the boat down, so while heading into a headwind it would start to beat the boat so bad heading against the waves, because the boat was achieving well over 8 to 9 knots, which is good success. It would be hard to beat somewhere around 8 to 9 knots straight upwind, when even if you're tacking and you're achieving speeds of 12, 13, which is pretty phenomenal for most boats, you're just not going to be able to keep up with that. Still not going to be anything that wins any races, but still amazing that that can be done with the crew of 1, all at the helm, not running all over the deck with all of the sheets and sails and booms and everything you have to deal with. Just a few controls at the helm and you're set to go. So one of the big issues that I see in the design is the propeller. A propeller is the most efficient way that we have found to transfer energy into thrust in the water. It is the most efficient. Is it the best for every specific situation? No, it's not. But it is the overall king of the water. Now, in tradition, for boats that were slow but needed lots of thrust, in this case, this situation, a boat, paddle wheels are something that I would like to see tested. And that is one of the goals that I have, is instead of running a propeller in the water, which is hard to scale down due to water molecules not shrinking with the boat. The propeller actually has to be out of scale, essentially, to create adequate thrust. A few other YouTubers who have created models have had some success. Nothing that would be merit scaling up to a larger scale, but is still had success nonetheless. But the first thing they found is that they had to run a oversized, a very large propeller in order to transfer that thrust from the rotor down to the propeller. So I propose, what if you could run a paddle wheel, which has lots of surface area and has a lot of thrust. Now, they are not great at speed. Paddle wheels have a speed limit that really made them fall out of popularity. But it was really hard to compete with the amount of thrust that they created. Is it the best power to thrust ratio that you get from engine size or power plant size to thrust? That is up for debate. But when it comes to slow speed and ease of converting the energy, I think the paddle wheel will be better. For one reason is when you are converting the rotor speed down into propeller speed, propellers in the water have to spin pretty fast. They can spin slow. Usually if they're larger they are, the more they can spin slow. But there will have to be some form of gearing up. The ratio has to be greater for the propeller. The propeller has to spin faster than the rotor. You're just not going to spin your turbine, wind turbine, that fast. So you have loss in that conversion of energy. Whenever you're gearing up or down, there is a loss. Now, technically, and just what I have seen in my own experiments, you do have a slightly less loss when you are gearing down. Hence, engines in your cars or rock crawlers and trucks and different stuff like that, they're able to take a very little amount of energy and convert it into an insane amount of torque. You're not going to get any speed, but you're going to get torque. And when you're fighting against either a current or a wind, and you have this massive surface area, which is this rotating surface area from this windmill, you have to fight that. And that's where the propellers spinning at slow speeds are having that issue. So I would like to see if the paddle wheel solves all those issues, because once again, paddle wheels spin very slow. The rotor up top, full scale, will be spinning in relations to a propeller. For a propeller in water, is spinning very slow. So you could get away with a 1-to-1 ratio on the windmill to paddle wheel, or even less with spinning the paddle wheel slower, which just amplifies the amount of torque that you have to push your hull through the water, fighting the wind and the waves. So that's the prime main test that I want to play with in this model. The second thing I want to, which has been done, most successful full-scale, whether small hobby sailboats or full-size sailboats that have used this propulsion system, have all been catamarans. Very, very few. Matter of fact, I can't find any videos, movies, or clips of them. But monohulls, there's only been one monohull, and that was the second boat built by Jim Bates. And I have some pictures of that. But very, very few on that. Very little information on that. But he had great success with the trimaran. I don't know where in the timeline the monohull came about, but you get some positive and negatives of a monohull. Everybody, I mean, if you're in the sailing world, you know the positive and negatives of trimaran, catamaran, monohull. You know the battle that those have always been having. That each have their positive and negatives. When it comes to with mounting of a single large mast to hold the main rotor, it would be much easier to mount that on a monohull. Also for payload, when it comes to carrying a heavy load, you're going to get much better on a monohull. So if you want to talk about actual practicality of functionality, if you want this to be a long haul cruiser of some sort, or a long river cruiser. For instance, I have the Columbia River here in the Northwest, very windy, gorge. Wind is always blowing, either east or west, always. It's rarely ever calm. It's a great place to sail, except for that in some areas it can be narrow, where this would be very practical design. Monohull, once again, being easier to put in a slip. Also, just having more volume inside. Easier also when it comes to choppier waters. The monohull does not rock with the waves as bad. It cuts through the waves quite well. They're displacement hulls, which generally are good for once you get them moving. They can still be very efficient. And so that's another aspect I would like to experiment and play with, is a very sleek, long, but very shallow monohull. Because once again, I'd like to operate this in the Columbia River area. They're, for the most part, in the actual shipping lane. It is very deep. You're going to get 50, 60, 100 feet. But I like to venture off into the side swampy areas, and you're going to get extremely shallow, couple feet of water at times. Now, it'd be hard to design any large-scale boat to handle in that amount of water, but hey, it's a challenge to be conquered. Another bonus of the paddle wheels: extremely low draft. Paddle wheels can go in much shallower water than any propeller can. So, yeah, so that's the initial pitch of the idea behind this catastrophe that I'm about to take on. So, where to start? Well, got to build some kind of hull for this concept. In my laziness, I decided, why build something if you can just find someone who already built one? So right here, I have this cute little steamboat model. I picked this up on Facebook Marketplace. It's about 32 inches long. It's about 6 inches wide, and the actual hull piece is just under 4 inches tall. It's just kind of an old little cute little steamboat. But when I saw it, I thought, you know what? I think it would work pretty good for this. First of all, it's very long and sleek, very low draft, and has a little bit of keel, very little. Something that's very easy for me to add weight to, or if needing, a keel added to it if it isn't stable enough. Originally, you can see, it was designed to have a little propeller, but this is just a fake little nailed-on piece of metal and a non-moving rudder. Obviously, it'd be very easy to add in a pretty large rudder here on the rear, but here I am talking about here on the aft of the boat here. If I put a rudder here, where's the paddle wheels going? So I propose side paddle wheels. So one on each side, one here, and that makes it easy for the drive mechanism, because now right here where this boiler is, I can put my mast with the rotor on it that will run down and run the paddle wheels direct. There's no need for a shaft going aft. Things are just going straight up and down. Once again, the folly of most of these designs is the drag in all the mechanics. You do too many gearboxes, you have too much loss in power. Every bit of power needs to be transferred to the water. It can't be lost in all these different types of gears. And later on, we'll go into the different types of gears, whether spur or spiral bevels and helical cuts. They each have their use and their positive and negatives. Also, whether 90 degrees or straight on, all of these things can cause drag, and so you minimize that to only 2 points two separate gearboxes with one shaft, you can drastically reduce that. So that's another bonus of having the paddle wheel design that I'm going to try. So let's go ahead and let's lose this. But nice thing is that it's easy for me to go ahead and reduce what's going on here. So we've got a nice little, cute little hull here. So got a lot of room here to already mount the gearbox and the shaft going through. How big, how wide paddle wheels, I don't know. We'll figure that out as we go. Who knows? So that is the initial pitch, and you're welcome to come along to laugh at my failure, or say my success isn't really a success. Whatever you want to do, I really don't care.